Harilivelela, Chabasa Somalia, Ugamutu, Narachula, Harilivelela, Chabasa Somalia, Ugamutu, Narachula, Mutumalima,
Most Somalis obtain water from boreholes and shallow wells. Shallow wells are typically located within settlements where water quality is often polluted due to nearby latrines seeping their contents into the groundwater. This causes frequent outbreaks of water-related diseases, such as cholera and diarrhea. Disinfection refers to selective destruction of disease-causing organisms in the water supply. The most widely used process to disinfest water is chlorination. Other processes include ultraviolet or UV light, ozonation, or reverse osmosis. Several tests and pre-treatments have to be conducted to ensure effective chlorination, such as turbidity and pH tests. The following videos will take you through the different steps of the chlorination process. After conducting the turbidity test, if the level of turbidity is still more than 5 NTU, or to 20 in emergencies, you should undertake a pre-treatment procedure to reduce the turbidity and then to ensure effective chlorination. The next experiment, called a jar test, helps us to choose the adequate amount of coagulant required to settle sediments in water through the process of coagulation or flocculation. Coagulation is the chemical process of bringing the particles together by using a coagulant, whilst flocculation is the formation of larger or heavier particles called flocks following the coagulation. Properly formed flocks will settle out of water quickly in the sedimentation basin, removing the majority of the water's turbidity. In an emergency situation, the most commonly used chemical for coagulation is aluminium sulfate, or AlSO3. In case aluminium sulfate is not available in the field, another natural coagulant that is commonly used is the Moringa seeds. It's however mainly used at a household level. One seed can treat up to 4 litres of raw water, depending on its turbidity. To conduct the turbidity test, the following equipment and materials are necessary. 1. 6 1-litre glass beakers. 2. 1 electronic weight balance. 3. Coagulant products such as aluminium sulfate, AlSO3, powder at a concentration of 100%. 4. A watch or clock. 5. A turbidity meter. 6. Surgeon's gloves. 7. 1 spoon. 8. A raw sample from the source. 9. Distilled water.
The first step is to wear gloves, protective gloves. As you can see, I've already put on gloves for protection. Second step is to prepare or to fill in 1 liter of water, clean water. Then measure 10 grams of aluminum sulfate. And slowly I put the aluminum sulfate powder. Okay, then after that, cover the jerrycan and then shake it like 1 minute to make sure that the solution is made for thorough mixing. The third step is fill in these beakers with 1 liter of water from the source. That's 1 liter of water, raw water, to be treated. Fill all the rest the same, and then we go to the next step. Once the beakers are filled with 1 liter water, we need now to dose these the different beakers, different dosages of aluminium sulfate solution. The first beaker, we are going to dose 1 milliliter of aluminium sulfate solution. The second beaker will dose it with 3 milliliter. Third beaker, we dose 5 milliliter. The fourth beaker, we dose it with 7 milliliter. The fifth beaker, we dose it with 9 milliliter of aluminium sulfate solution. And the last one, that is the sixth beaker, we dose it with 11 milliliter of aluminium sulfate solution. The next step is to stir the 6 beakers for 1 minute rigorously. 1 minute rigorously. Like this. Once we stir for 1 minute, the next step is to stir slowly for 15 minutes to ensure that the mixture, the aluminium sulfide, mixes with the suspended materials in a process called flocculation. After stirring for 15 minutes, allow for a period of between 30 to 60 minutes to allow contact time of aluminium sulfide and the suspended materials to come together and settle down. We have now waited for 60 minutes. The next step will be to determine the turbidity of each solution of all the 6 beakers. Procedure is as follows. We use the turbidity meter, hold gently the beaker for the first dose and then pour the water as you watch the cross down there to just determine which level of the water will be, and the cross disappears. Remember to hold the beaker gently so that you don't disturb the settled sediments. The cross has just disappeared and the turbidity of water is still 40. It's 40. That means nothing much has changed for the first beaker. Then we will repeat the process in all the remaining beakers, determining the turbidity for all the 6 beakers. Now we have determined the turbidity of all the 6 beakers. As you can see, the first beaker, the turbidity is 40 NTU, the second is 8, the third is 6, the fourth is 5, less than 5, the sixth is 7, and the last one is 8. You can see the turbidity test. From the turbidity test, the level of NTU goes down up to the optimum level and then up again. That the level at the point where it is minimum, that is the optimum level of dosage. That is the optimum dosage which is required. What happens is, if you have less aluminium sulfate in the water, the formation of flux is far much less. If you have more in the water solution, it means that the aluminium sulfate interferes with the settlement process, and that means the settlement does not take place as required.
The technician has found that the optimum amount of aluminium sulfate at a concentration of 1% is 7 ml per litre. Let us now calculate the quantity of 100% aluminium sulfate powder needed to pre-treat a water tank of 15 cubic metres. First, we must calculate the amount needed for 1 litre. To obtain the stock solution of 1% aluminium sulfate, we used 10 GL, which is the equivalent to 10,000 milligrams, or 1,000 millilitres. To obtain 7 ml, we used cross multiplication as follows. 7 ml times 10,000 milligrams equals 1,000 millilitres. The amount of 100% aluminium sulfate powder needed for 1 litre is then 70 milligrams. Now we need to convert our 15 cubic metres into litres. If 1 cubic metre is equal to 1,000 litres, then we can work out that 15 cubic metres is equal to 15,000 litres. Then, if for 1 litre of water we need 70 milligrams of 100% AlSU powder, how much would we need for 15,000 litres? By simple multiplication, we can work out that we would need 1,050,000 milligrams, or, which is the equivalent to 1,050 grams or 1.05 kilograms of 100% aluminium sulfate powder. We now have the amount of aluminium sulfate needed to reduce the turbidity of our 15 cubic metre tank. However, to ensure the effectiveness of the process, the pH of the water should be between 6 to 7, which is the pH we are looking for water consumption. We will then need to conduct a pH test with our water sample.